It's a pleasure to greet you. We are going to present a linear algebra topic related to economics called linear economic models. The team is conformed by Luisa, Paula, and me. So let's continue with the introduction. First, we have to know that linear algebra is applied in different fields of business, in structural design, engineering, and it is extremely useful for everything, in financial aspects and business organizations. Linear algebra is a significant instrument since through this can be used, and linear algebra has proven to be a powerful tool in developing and analyzing models. In this case, we introduce two models, the open model and the closed model. The closed model means that no output from an industry become inputs for other industries. Essentially, the industry uses all of his outputs. The open model means that other industries consume another industry's products. The open model illustrates that different sectors of the economy directly influence one of another. Based on the work of Harvard economist Leontief in the 1930s, his methods often referred to as an input-output analysis, and now standard tools in mathematical economics and are used by cities, corporations, and entire countries for economic planning and forecasting. These sectors are dependent on each other, and the total input always equals to the total output. In 1935, Wasily won the Nobel Prize in Economics for his work in this field. And in this presentation, we're going to talk about the open economic model. The open economic model is a realistic model, as it deals with the economic where sectors of economy not only satisfy each other's needs, but they also satisfy some outside demands. In this case, the outside demands are put on by the consumer. In the open economic model, there are n industries producing n different products such that the input equals to the output, or in other words, consumption is equals to production. In an open model, some productions consumed internally by industries, rest consumed by external bodies, and the only problem of the open economic method is for find the production we need to have the external demand. And now we're going to present some examples of this method.
So now we're going to use an example in order to explain the topic better. Let the n industries denoted by S1, S2 until Sn. Here Aij denotes the number of units produced by industry Si, necessary to produce 1 unit by industry Sj, and Bi is the number of externally demanded units of industry Si. The following equations are satisfied. The production of food industry in tons and the car industry in 1,000-kilometer car travels. The total output equals the internal consumption plus the external demand. In this case, the total output is X equal to 0.05X plus 0.5Y plus the external demand, which is 8,000. And for the car industry, it is Y equals to 0.01 X plus the external demand, which is 2,000. In general, we let X1, X2, X3 until Xn be the total output of industry S1, S2 until Xn, respectively. For example, in this case, X1 equals to the A11 X1 plus A12 X1 plus A1n X1 plus B1. So then we can use all this data until Xn equals AN1 X1 plus AN2 X1 plus ANN Xn plus Bn. Then since Aij Xj is the number of units produced by industry Si and consumed by industry Sj. The total consumption equals the total production for the product of each industry Si. Let a matrix of A and a matrix of B and a matrix of X exist. A is called the input-output matrix, B the external demand vector, and X the production level vector. The previous system of linear equations is equivalent to the matrix equation X equals to AX plus B, the open model. So then we have the A and B different to the zero matrix are given, and the problem is to determine X from this matrix equation. We can transform this equation as follows. We can bring A multiplied by X to the other side by subtraction. Then we can subtract A to the identity matrix and multiply it by X, and that equals to B. Then what we have to do is to get the inverse of the matrix, so we can get X equals to the inverse of the identity matrix minus A matrix multiplied by B. If the inverse of the matrix identity minus A exists, then it is called the Leontief inverse. For a given realistic economy, a solution obviously must exist. For example, here we can see that A is a 2 by 2 matrix, B is a 2 by 1 matrix, and X are the X and Y matrix. So we obtain the solutions by computing all the matrix and doing all the operation of the matrix. So the next step is just to make all the operation matrix, and what we get at the end is that X equals 10,000 in X and Y is 3,000. So we have that X equals 10,000 tons of food and Y equals 3 million kilometers of car travels. That is due to, at the beginning, we state in the equations that it was going to be measured by thousands of kilometers that the car travels. So then when we get 3,000, we just have to multiply 3,000 by 1,000 and we get 3 million. So then if we have external demand, for example, if we have B prime equals to something, we get that X prime equals to the inverse of the identity matrix minus A matrix multiplied by B prime. And then we just have to solve all the matrix operations. One difficulty with the model is how to determine the matrix A from an already given economy. Typically, X is known, B is known, and A, I, J, X, J, when I and J equals to 1 until N, is known. One takes therefore the matrix AJ, XJ, when I and J equals to 1 until N, and divides the G column by XJ for J equals to 1 until N to get a matrix.
Now we are going to give the last example. An economy has the two industries, A and B. The current consumption is given by the following table. Assume the new external demand is 100 units of A and 100 units of B. Determine the new production levels. According to the previous table provided by the example, we should add the internal and external consumption of both companies. From company A, we obtain a total consumption of 120 units, and from company B, we obtain a total of 200 units. Then we have the matrix X that represents the new production levels we are trying to find. In this case, X would be a matrix with two values, one for A and one for B, representing the new production quantities. A is a matrix that contains information about the current production in both industries, A and B. The matrix A is used to calculate how the current production relates to future production. B prime is a matrix that contains the new external demand for both industries, A and B, which is 100 units for each. Now we are going to use the formula for the open model. At the end, applying the formula, we obtain that the new production levels are 307.3 and 317 for A and B respectively. In conclusion, we have noticed that linear algebra has several applications to make our life simpler and solve problems related with numbers in a faster way. In the economics, the method we presented has a strong importance due to the operation it implies and the fact that it has the purpose of correct distribution of goods in a society. If we apply linear algebra correctly, it can help governments and leaders to take the best economic decisions for their country. Thank you.